Hello again, two-stroke fans. Now we're on to episode 7, I think. All the previous episodes, I'll put in a link up there to the playlist to watch. They're short videos, so you can just watch as many as you can handle and come back to the others later. In the previous ones, we have covered the basics of the expansion chamber, the timing of the waves and what the waveforms are, and the angles of the diffuser and baffle cone for the shape of the wave that we want, compression and expansion wave. And all of that has been for a single cycle of operation. Now we get into the next bit of complexity, which is multiple cycles of operation. Obviously, if the engine's revving at thousands of RPM, there is many pulses coming into the exhaust expansion chamber and filling up the expansion chamber. So this one, first of all, we'll get into the pressure side of issues. And then later we'll get into some issues of resonance and multiple waves and how they translate to one another. But for the moment, the outlet pipe. Bleed tube. What that effectively does is it bleeds down the pressure into the outlet. As the RPM rises and we've got more pulses of gas coming in, pipe's bigger at this end, smaller pipe, obviously pressure is going to build up as the engine revs build up through our power curve. And we're going to have an increasing amount of pressure in the expansion chamber. Now, the position of that pipe is non-critical because the baffle cone functions as the baffle cone functions in these three types, the same as always, and the pipe simply bleeds off pressure. Now, in this configuration, if we push the tip of the pipe forward to just ahead of the mean point of reflection, and the mean point of reflection is halfway from the tip, the tail halfway, the mean point of reflection, we just knock off that top stinger, that crackling sound off the pipe, and just squirt it down a little bit. We can also have a side exit one, which you may have seen, which is a bit more compact. Now the function of that is a matter of its diameter and its length, so that's quite critical. And obviously, if it's longer, it has to be a wide diameter to pass the same amount of gas through in the same amount of time. Okay, so this is effectively bleeding down and ensuring that we've got some pressure inside the pipe. Now, the back pressure inside the pipe will have a more uniform temperature through the pipe, so that'll help wave speed a bit. But mostly, the outlet pipe is to regulate the pressure on one side of the engine in relation to the other side, which is the intake. So what's going to be happening as we get up to our power curve, we've got our expansion waves coming back in and helping to aid more intake charge coming in. And now remember, the intake charge in a two-stroke is pressurized from the crankcase. By the piston going down, it pressurizes and pushes the air in. Okay, so the pressure comes in from the intake, pressurized intake, and as the RPM rises and our bleed tube builds up pressure inside the pipe, we get an increasing amount of pressure opposing it. Now, remember my explanation about the waveform reflecting off the baffle cone and coming back and using the pressure pulse at the right moment before the piston closes to stop escaping gases. Well, that's not the only thing that does that. Back pressure has the same effect. So the more back pressure we get in there as the RPM rises, the more pressure we've got against intake charge spilling out of the exhaust. Okay, so we've got pressure coming from the crankcase, we've got pressure coming from the exhaust pipe building up, and that is having an effect of port plugging more and more. When we get to a certain RPM, what we're going to do is we're going to fill the expansion chamber up, and we're going to get exhaust coming back into here. Okay, so that is not good. So what we've got to do is we've got to closely regulate the size of the outlet pipe, quite critical in size actually, to regulate the pressure inside here so that over our RPM curve we get a reasonable amount of pressure opposing spillage of the intake out. And then as we get to our power peak, we then get the baffle cone reflecting the compression wave back and doing the final port plugging before the piston shuts. That relies on all things being good, but I'm going to get into another issue is we've got to look at the bigger picture, okay, is when we've got rising exhaust pressures, that relies on us having good intake pressure. But if we've got a deficiency at the intake, for example, a piston port engine with symmetrical timing, we've got limitations on how much timing we can give it. It's going to get to a certain RPM where we're not going to have very much pressure coming in, and conversely, we can't have very much pressure on this side. Otherwise, we'll get that pushing of exhaust right up back into it. So the next part of it will also get into what we're also going to have to look at is the intake side in relationship to our pipe, okay? Because we can't just look at the pipe alone, because the pipe, an issue particularly like this, the outlet size, will be inextricably linked to how much intake we've got, okay, as to whether it's a piston port or a reed or a rotary disc valve intake. But what I'm working into there is that there's expansion chambers and expansion chambers, and they're not all the same. And so, thus far, I've been talking about the model of expansion chamber, which is relying on everything being good intake, good compression, etc., and good timing will ensure good operation of the pipe. But what if we haven't got that in an engine? What are we going to do then? So what this leads to is how to select the right pipe for the engine you've got, and then what things you might need to do to the engine to get the best out of the pipe that you're using, and how you might actually modify your pipe in some ways to adapt it to the situation you've got with your engine. So we'll leave that until next week. Have a good week, stay safe, and bye for now, folks.